So in this mini lecture, we'll call it Implicit Differentiation Part 2. In this mini lecture, we're going to deal with a certain cubic. It's called the Folium of Descartes, and it's represented by the graph that takes this shape. Right? So I'll write down an equation for the Folium of Descartes. So we're going to start off with something that looks like this. It says if x to the third plus y to the third is equal to 6xy, we're going to find y prime. Right? Find y prime. Let's do that. So we start on a blank sheet, and I'll write this over again for us. The Folium of Descartes was x cubed, at least the one we're using is x cubed plus y cubed equals 6xy. We're going to say find y prime. Alright, so it looks to be an implicit differentiation problem, of course, because we have x cubed and y cubed equals 6xy. So here we have to take the derivative of both sides of x cubed plus y cubed, and then take the derivative with respect to x of 6xy. Right? So next, in taking the derivative of x cubed, we can just use the simple product rule, the power rule, which will have 3x squared. This will be a little bit different because this is where we have to apply the concept of the differentiation that is implicit. Y is a function of x. However, this looks to be a chain rule problem as well, right? Since y is a function of x. So we do the outer according to the chain rule, which is the 3. The inner stays the same. Y squared. Right? So derivative of the outer and the inner stays the same, and then you multiply times the derivative of the inner. So the derivative of y with respect to x is 1, which is dy dx. The derivative of y with respect to x is just this, derivative of y with respect to x. Now on this right hand side, it looks like we need to apply the product rule. 6x can be an f of x and y can be the g of x. So in the product rule, we're told to take the derivative of the f of x, and I called the 6x our f of x and the y our g of x. So take the product of the, take the derivative of the 6x, which is 6, times the g of x, and you add it to the f of x times the derivative of the g of x. Now the derivative of y, as we stated earlier, because it's implicit differentiation, we're going to say is dy dx. Alright, so the next thing we do here is get the dy dx's on one side with everything else on the other side. So we have 3y squared dy dx minus 6x dy dx, and on this side we'll have 6y minus 3x squared. Alright, so now we're basically going to just solve for dy dx. So to solve for dy dx, we need to factor out a dy dx here in these two terms. So dy dx, 3y squared minus 6x equals that right hand side. And so all I did in the left hand side was just factor out a dy dx in these two terms. Alright, so we had dy, take that back. We had dy dx, and we had factored that dy dx out, so we had 3y squared minus 6x equals 6y minus 3x squared. And then we just solve for dy dx by dividing both sides by 3y squared minus 6x. So 6y minus 3x squared over 3y squared minus 6x. Alright, dy dx is equal to, we just do a little bit of factoring by GCF here. Looks like 3 is the GCF for the numerator and denominator. So it looks like we have 2y minus x squared, and down here we have y squared minus 2x. 3's cancel out, and we're left with 2y minus x squared over y squared minus 2x. Oops. Clean that up a little. And box in our answer better than that. So we have our final answer. 2y minus, oops, sorry about that. 2y minus x squared. 2y minus x squared over y squared minus 2x is the derivative of our Folium of Descartes equation of x cubed plus y cubed equals 6xy. Alright, let's add on to that a little bit. Right? Add on to it a little bit. And let's just say that they wanted us to do something else in this problem after we found the derivative of that. So what do we have here? It's going to say maybe find the tangent. Find the tangent of x cubed plus y cubed equals 6xy. Well, we've already found the derivative, which is 2y minus x squared over y squared minus 2x. So they're saying find the derivative, and they'll have to give us a certain point. So they'll say at point 3 comma 3. Well, we know x is 3 and y is 3. So all we do here is plug in. So we have 2, y is 3 minus x is 3 squared. 3 squared here minus 2, 3. And we get negative 1. So therefore negative 1 is the slope of our tangent line, because we know what the definition of a derivative is for us. So therefore we have the slope of a tangent line and we have a point. We must use point slope form. So now it's a matter of substituting in y, we said was 3, the slope is negative 1, and the x is 3. So here we have y minus 3 equals negative x plus 3, and maybe they would like us to put it in standard form or general form. So we'll get x plus y equals 6.